my card away.
I hope that's a good idea, sir.
All right. I remember something about if the count is low, I'm supposed to split or something like that. I don't know what to do here. 20 is a good number though. Basic strategy says it should stand. So you know what? I'm gonna stand.
Basic strategy does say that, sir. Let's hope you're lucky. 7. 2. A 5. We hate to see that, sir. We hate to see it.
My wife is gonna kill me. If only there was a way I could learn how to count cards correctly. I keep messing it up, but there's no way to learn this well.
But there is now. Introducing Blackjack Buddy.
Okay, now we will introduce our project, which is Blackjack Buddy. Now, as we described earlier, the problem is that the user is unable to learn what the optimal move is in real time, and thus they are unable to quickly learn the skills required for the game of blackjack in an effective manner. So our tool, Blackjack Buddy, is an educational tool to help users practice this skill. And we support several different modes, such as basic strategy, as well as many different types of card counting techniques. And the biggest thing we aim to provide is a real-time feedback system via an interactive web application that the user can interface with cleanly. And this will, if used correctly, this product can help users get a positive expected value profit and help them with their decision-making. And this will help in social settings where a user just wants to play with their friend. The main use case requirements here, we'll go over briefly, is we want to detect the cards correctly, mostly correctly. 90% is our goal here. We also want the time of the cards being dealt to be to the optimal choice being made to be less than 1 second. We also want the processing algorithm of our optimal decision making to output the optimal decision 100% of the time. We also want this web application to have a very flexible and intuitive UI so that the user has a pleasant experience when interacting with it. And the table that we use should be independent of the setup that we have. So this should work on any table that we want. So let's go through a bit of the flow of the whole thing. So as cards are being dealt with this on the table, the Logitech camera that we have will send frames of these cards and send it over to our Jetson. This Jetson Xavier NX has a machine learning model, and it will take these frames and output what cards it thinks it sees. And these cards are fed into the decision-making algorithm, and this is our processing algorithm. And the processing algorithm takes this input and then decides what is the best move that the user should do next. It sends this feedback, in this case, in the diagram it is hit, and sends it to the web application. And this web application sends it to the interfacing device. The user can do this on a smartphone, for example, and then it sends this to the user. The user also has input into this. Let's say the user wants to bet 10, then they can send that to the web app, and then the web app can send that to the decision-making algorithm. And then this algorithm, depending on the betting strategy that the user decides to choose, can say, okay, see, if you bet 10 earlier, and let's say you're doing the martingale format where you double your bet every time you lose, then now you should bet 20. So this processing algorithm will not only tell you what the best decision is, it will also tell you what you should bet on your next turn, assuming you have a strategy followed. So that is the basic flow of our product. And we came up with a bunch of different tests. Camera latency, detection latency, and processing latency are all parts of the pipeline that the card has to go through before a decision is made to the user. These all meet spec. The detection accuracy, one of the important ones where the card is detected even under occlusion with the sets of 3. So even with 3 cards placed basically on top of each other, it detects it very well. We, of course, output the optimal choice every time. And we have also sent surveys to people with various questions asking about the user experience and whether they have come into any confusions when dealing with this algorithm. And it seems like users have understood the functionality very well.
So briefly, this is what the physical design looks like. It is a box with the camera attached to it that will look at the cards here and send frames. Inside this box is a camera mount and a Jetson Xavier NX that has wires connecting out to keyboard, mouse, and monitor.
So welcome to Blackjack Buddy, and basically it's going to be an app that helps people learn how to count cards and play more effective blackjack. So you start by logging in to the app. So as responsible engineers, we make sure that there's warnings, and we continue. So there's multiple game settings you can pick from. So for example, counting strategies, there's different counting strategies that you can pick from, and it gives a detailed explanation of what each counting strategy actually is. So let's just pick high-low, for example. Same thing for betting strategies. There's a couple of them that we offer. We'll go with count-based. Player position basically describes where you are playing. So this game actually supports up to 5 players, excluding the dealer. And the number of shoes. So we'll just stick to 1 for now. So then you can put in unit bet. Unit bet, it's basically the standard bet that we'll be playing with. So we submit. So this will bring us to a screen where it shows your current profits over the last 10 rounds and the bet amount that you want to put. So because we haven't played any rounds, the optimal bet is not available for seeing. And let's just put in a random number like 10. Okay, so now a game has begun, right? So it tells us the current bet is 10, and there's no counter optimal play being provided because there are no cards down yet. So now we'll show you how the cards are dealt and detected.
So I will walk us through a simple game of blackjack, and I will explain the model a little bit more. So as a dealer, I will deal to the player, make sure it's in frame, and then I will deal my card, and then I will deal the player's other card. So as we can see, the model is able to pretty robustly detect cards on their own, but also cards with occlusion. And the main reason that we need that is that in blackjack, cards are usually dealt in this way, and we want to be able to handle these cases where we can only partially see the card, and we don't want to have to like always rely on the rectangle, right? And the key point that we know about occlusions is that we're actually detecting these small boxes up here, and that allows us to robustly do that. But then that means that we have to do extra processing, mainly with k-means clustering algorithms, to make sure that we're only detecting one card at a time, such as this 2, which we can very clearly see is detected only once.
So as you can see, the cards were showing 8 and 9 for the player. So the player shows a heart 17, and the dealer shows a 2, which is what we saw earlier, and it detects that the count is correctly 1. And it also tells you the suggestion. So right now it just says to use basic strategy and stand. And there are different options for what are the result of the game. So if you win, you press in a win. If you double, let's say you double, it will tell you your current bet has just doubled, and then you give the outcomes whether you got blackjack, whether you pushed, you lost, or you won. So let's say you win in this case, your current profits is actually going to be updated. So now we're going to play another round, continuing from where we were before, where the count was at 1. So we're going to deal another set of cards. Yeah, so now it's updated again with the player showing hard 9 and the dealer showing 2, but it recognizes the count is actually really high, and instead of doing what basic strategy would say, which is to hit, it's actually suggesting that you should deviate and play double, which is the correct deviation for this. So likely you're gonna double this and you win a lot of money.